Welcome to Platform Engineering, your blueprint for a high-impact tech career. This comprehensive guide is for technologists who want to build the infrastructure that powers the modern software world and earn exceptionally well doing it. This program is brought to you by the Series of Thoughts team as part of the Career Guidance series. What is platform engineering? It involves three core concepts. First, internal developer platforms, or IDPs, enable efficient application deployment and management. Second, self-service infrastructure, which abstracts complexity so developers can focus on writing great software. And third, developer autonomy at scale, providing opinionated tooling that accelerates every engineering team. The why? Solving the complexity crisis. Platform engineering addresses cognitive load overload by simplifying complex systems like Kubernetes and CI/CD pipelines. It meets speed and efficiency demands for faster deployment and higher reliability. Lastly, it handles the cloud-native reality by designing scalable platforms for distributed environments. Platform engineering versus DevOps. Platform engineers create abstracted, self-service tooling, treating the platform as a product for internal developers. DevOps engineers focus on collaboration and process improvement, bridging development and operations. The two roles are complementary, with many platform engineers starting as DevOps engineers before specializing. The superpower of a great platform engineer is abstracting complexity and empowering developers. They take overwhelming technical complexity and transform it into elegant, simple, and reliable tooling that developers can use with confidence. Chapter 2, the Platform Engineer's Toolkit. Becoming a platform engineer requires mastery across a broad and deep stack of technical skills, from the operating system layer up to developer experience tooling and observability platforms. Core technical skills form the foundation. These include Linux fundamentals for understanding operating systems, deep networking knowledge, and mastery of scripting languages like Bash and Python for automation. Version control, specifically Git, is also critical for modern platform environments. Cloud and orchestration are the pillars. Multi-cloud expertise in AWS, Azure, and GCP is essential for designing portable and cost-optimized platforms. Kubernetes mastery is non-negotiable for container orchestration. Infrastructure as code tools like Terraform and Ansible are the cornerstones of platform automation. Observability and CI/CD are the lifeblood. Monitoring and alerting rely on tools like Prometheus, Grafana, Datadog, and Elasticsearch for metrics, visualization, and log analysis. CI/CD and containers, using GitHub Actions, GitLab CI, Jenkins, and Docker, form the backbone of modern release processes. Chapter 1, the rise of the platform engineer. As software systems grow more complex and cloud-native architectures become the norm, a new discipline has emerged at the intersection of infrastructure, automation, and developer experience: platform engineering. The essential stack includes 4 layers. The infrastructure layer uses Terraform and CloudFormation. The orchestration layer relies on Kubernetes and Docker. The cloud layer involves providers like AWS and Azure. Finally, the observability layer uses Prometheus and Grafana. Beyond technical skills are the soft skills. A customer-centric approach means being an empathetic partner to engineering groups. A product mindset involves treating the platform as a product with real users. Strong communication and collaboration are vital for driving technical decisions and building great platforms. Finally, continuous learning is essential in this rapidly evolving landscape. Chapter 3, charting your career path. Platform engineering offers one of the most rewarding career trajectories in tech, with defined growth stages, strong compensation, and multiple paths for advancement. The initial career stages involve getting started. The entry level, 0 to 2 years, focuses on fundamentals as a junior platform or DevOps engineer. The mid-level, 2 to 5 years, involves leading small projects and contributing to architectural decisions as a platform or site reliability engineer. This is where specialization begins. Career stages for growth and leadership start at the senior level, 5 to 8 years. As a senior or staff platform engineer, you architect complex systems and lead cross-functional collaboration. The leadership level, 8+ years, is for principal engineers or engineering managers who set technical direction and build high-performing teams. Climbing the platform engineering ladder brings new challenges, greater scope, and significantly higher compensation. The path rewards those who combine deep technical depth with leadership and strategic thinking. Platform engineering offers excellent typical salaries in the US, Entry-level ranges from $80,000 to $120,000. Mid-level is $120,000 to $180,000. Senior-level architects can earn $180,000 to $250,000. Leadership roles start at $250,000 and can exceed $400,000. Total compensation packages often include significant equity. This chart illustrates the substantial salary growth across career levels. The jump from mid-level to senior is particularly significant, reflecting the value organizations place on engineers who can architect and own complex platform systems end-to-end. Alternative career paths include the individual contributor IC track for those seeking technical depth, moving up to distinguished engineer. The management track is for those seeking people leadership, progressing to VP of engineering. Specialized paths like platform architect or chaos engineer also exist. Chapter 4. Landing your dream role. Getting into platform engineering requires more than technical chops. It takes a strategic approach to job searching, networking, and positioning yourself as a candidate organizations compete to hire. You can find opportunities through job boards and specialized sites like Dice and Stack Overflow Jobs. Networking and community events like KubeCon and local meetups are excellent for insider referrals. Also, build relationships with specialized recruiters and apply directly to company career pages. Target top companies like tech giants for the highest compensation and most complex challenges, or cloud providers like AWS for unique scale. High-growth startups offer equity upside and ground-up platform building. Enterprises and consulting firms need urgent platform expertise during digital transformation. To optimize your resume and stand out, quantify your impact using numbers. Tailor your resume to mirror keywords in the job description. Highlight key certifications like CKA and CKS. Finally, showcase working code via your portfolio and GitHub. Quantifying your impact is critical. Instead of saying, worked on CI/CD pipelines, say, reduced average build time from 18 minutes to 4 minutes, enabling 3x daily release frequency. This distinction sets exceptional candidates apart. When negotiating, understand total compensation, including equity, bonuses, and benefits, as equity can double your effective compensation. Negotiate strategically by researching market rates and never accepting the first offer. Get everything in writing. Chapter 5. Thriving in platform engineering. Getting the job is only step 1. Building a long, fulfilling, and impactful career requires mastering the technical, human, and personal dimensions of this demanding but rewarding discipline. Embrace technical challenges by going deep on distributed systems fundamentals. Own container orchestration, mastering Kubernetes deep inside. And finally, drive decisions through knowledge, using your technical credibility to earn trust and shape architectural recommendations. The human factor is vital. Invest in cross-functional relationships with development and security teams. Practice empathy in engineering by listening to your developers' pain points, which inform your roadmap. Aligning your platform goals with the broader organization ensures shared success. Platform engineering can demand a lot, carrying the weight of production incidents. Recognize these demands and invest in yourself by prioritizing rest, exercise, and mental health. The most impactful engineers prioritize rest as seriously as they prioritize uptime. Failures are inevitable, so learn from mistakes by conducting blameless postmortems focused on system improvement, not individual fault. Practice resilience engineering by turning every outage into platform hardening. Embrace a growth mindset, where failure accelerates learning. The most successful platform engineers don't seek perfection. They seek progress. Innovate through iteration, applying the quote, build, measure, learn, and improve cycle. Every iteration makes the platform more reliable, more developer-friendly, and more aligned with the organization's evolving needs. Staying current is vital in this ever-evolving landscape. Follow technical blogs and newsletters from industry leaders. Attend major conferences like KubeCon and contribute to open source projects. Seek mentorship and work on side projects to experiment with new, emerging tools risk-free. Chapter 6. The future of platform engineering. This discipline is not a trend. It is the structural foundation for how software organizations will operate in the AI-driven, cloud-native era. The trajectory is pointing sharply upward. AI's role is key. 94% of organizations find AI critical to platform engineering's future, but 62% struggle to find qualified talent. Platform engineers must harness AI for anomaly detection, predictive autoscaling, and automated incident response. The IDP imperative is strong. Gartner predicts 80% of engineering organizations will have an internal developer platform by 2026. IDPs are the central nervous system, standardizing infrastructure access and eliminating duplicated effort across large engineering organizations, driving developer productivity. AI-powered platforms are the next frontier. The platforms of tomorrow will be self-healing, self-optimizing, and AI-augmented. Engineers who understand both infrastructure and AI capabilities will be the most sought-after professionals in the industry. This field offers high demand and high reward. With a 62% talent shortage, platform engineers earn a 42.5% salary premium over DevOps roles. Gartner forecasts 80% IDP adoption by 2026, driving sustained global demand. Chapter 7. Your platform engineering journey starts now. Every expert began with curiosity and a drive to build something that matters. The path is demanding, but the destination is exceptional. Embrace this journey. Key takeaways for techies include embracing complexity, being a product owner focused on developer experience, and mastering the core stack. Most importantly, develop your soft skills and commit to continuous, lifelong learning. The demand is real, the salaries are exceptional, and the impact is profound. Platform engineering is one of the most strategically important and rewarding careers available today. The blueprint is in your hands. The only step that remains is yours to take.